All right, I'm Joe, and this is Sean.
Hi.
And yeah, we're going to walk through how a block gets executed. So we're going to work in this module that's just called executive as part of frame. And Sean, maybe you want to give us an idea of like how this fits into frame.
Yeah, absolutely. So obviously in this frame folder, we have a bunch of different palettes and some of the supporting like libraries and modules needed to get frame working. Executive is not like the other palettes in this folder because it's not a palette. It does not have declare module, declare storage, declare events, or anything like that. It instead has a bunch of logic, which is wrapped around what we assume in frame to basically allow you to execute and run through the block process. So when you're actually writing some of your code in your different palettes, you have things like functions which may start at the beginning of a block, the actual execution of all the different palettes, like the ordering of them, and then finally things that might happen at the end of a block. And the executive module basically handles all of that logic.
Yeah, so like as a runtime engineer, you're probably not going to be working in executive, but it's good to understand what it does so that you know some of the functions that are available to you, and then also like the context that your dispatchable functions are being executed within.
Yeah, and I think one thing to point out is that again, you're not going to be touching this very much, but understanding how it works is very important because there may be things you assume about your runtime. For example, that one function or one palette will always run before another palette. The executive module actually has the logic in there which determines the ordering of these things. So, we even, I think at one point had an issue where we reorganized the order of our palettes by alphabetical order, but this actually killed some assumptions in our consensus layers, which basically assumed that, one process would happen after the other. And so it's important to understand maybe why these issues might occur and how you can avoid them.
Yeah. So yeah, let's just start out with like the oninitialize and onFinalize functions.
Yeah. So, I guess, let me see. The best place to probably look at that is in another palette. Let me think. I'm thinking, what if instead we just walk through, like, kind of just read from top to bottom the executive, and then we can take a look at maybe how that applies to a specific palette?
Yeah, sure.
With oninitialize, yeah, because I mean, the first thing that will happen in terms of any block being executed is this oninitialize, but there's some kind of steps that happen beforehand the executive handles.
Yeah. Okay. So I'll back up and like ask a new question.
Yeah,
So we
sure.
can cut. All right. So yeah, let's get started on like first of all, what is a block, and then what happens when this block gets executed.
Yeah. So I think blockchains are actually quite simple objects to be honest. They are composed of these different blocks, and these blocks have like a set of transactions in them. And these transactions tell your blockchain how the state should change. So these transactions may execute different functions in your runtime, may execute different behaviors, and ultimately all of these things may change an underlying state of your blockchain. And if everyone follows these rules, they all get to the same state, and then we have achieved, some form of consensus. Or we can go through a consensus process to agree that we all have the same state.
Right. So like a block in Substrate, it has a header with some fields in it, and then the actual body of the block is just a vector of extrinsics,
Exactly.
which are state changes.
These state changes.
And so the executive module is the logic of how we execute each of these extrinsics.
Exactly.
So yeah, let's start walking through it.
Yeah, so I think one of the easiest ways to walk through executive module is just by reading it from top to bottom. It actually follows a pretty common flow, and I think it's pretty understandable and readable. So let's see. Let's start with, so of course we have an execute block function, and this is going to start the whole process of, like what's actually going to happen. You see it actually calls into another execute block. We can go here, we can see something like, at the very beginning of a block, we're going to initialize the block. We're going to have to do we're going to manipulate things like with the header, right? We're going to do things with digest. Digest, I don't know, maybe you have a better explanation, but it's mostly, from my understanding, used in the consensus. It's like I don't know, I guess I want to use the word digest in my explanation of digest, but basically it's some package information allowing you to work with the different consensus algorithms. Is that?
Yeah, I actually don't have a great understanding of it myself, but I think it's like it has like the slot number, the block author, all the stuff that's like proves that this block author had the right to make this block.
Yeah. And again, as a runtime engineer, I've never actually touched this myself. Maybe getting a consensus expert on the show would be a great way to talk about it. But in my mind, I think about it as these are the things needed in a block to be able to get to consensus about what blocks are valid. Okay, we have the initialized block implementation. Okay, so this is the first time we're going to be seeing something familiar if you're a runtime developer. So if you're a runtime developer and you're building a palette, one of the tools you have available to you is this onInitialize function. And the onInitialize function basically allows you to run or execute some logic at the beginning of every block. So this can be really useful for a number of situations. One I can think of off the top of my head is a storage migration. So let's say that you introduce some new storage items, or you have some kind of change in your logic which needs to assume the storage is in a different state. You could actually create an onInitialize function so that the right after your runtime upgrade occurs, we will actually go and migrate some of the storage from happening, or from one state to another state. Another situation you might be using onInitialize is just basically to do anything at the beginning of a block, right? Like there might be some kind of like automatic timers, like every 5 blocks do this, or in all of our consensus stuff and staking, we have like these session changes and these other kind of things which happen on these cycles. And so unlike the normal smart contract world where basically all changes to your state must be executed by a transaction, here we can have our blockchain automatically execute some logic on some kind of block-based time cycle.
Yeah, so you could put like a check that says, if block number mod 1000 equals 0, then go do something else. So like every 1,000 blocks, you just want to go run some process.
Exactly. And so that's all controlled by this onInitialize. And so you'll see that when you write a palette, you can define an onInitialize function and describe some logic. And this line actually is doing some clever stuff to be able to call all of different onInitialize functions. And so if you actually take a look at the syntax here, it's a little bit funny. But it says this is all modules as onInitialize. And this all modules object here is actually something that's generated for you automatically by the construct runtime macro. So this is where you list all of the modules. Maybe I can just jump to it real quick.
Yeah, just pull it up so people see it.
Yeah, but what it does is basically it just has it's a tuple of all the different modules in your system. So if I go here and I do search for a construct run and I go down. Yeah, you'll see here that this macro has a list of all of the different palettes that are included in your runtime. And basically, it will also generate a bunch of other objects to make things nice and easy to work with. One of them is this all modules tuple, which basically lists all of the modules. And it will create that tuple in order of these of the list here. So if I have a different order of these palettes, it will actually change the order of the tuple. And then when you go to the executive and it's calling this onInitialize, it's actually calling this function for each of the different palettes in this tuple in order.
Yeah, so it's going to grab this all modules tuple and go through and then check, does this have an onInitialize function?
Yeah.
And if it does, then it's going to execute it.
Exactly. And so when I was mentioning earlier before about, like the ordering matters, here if you assume, okay, well, this function must be initialized before this function runs, you need to make sure that in your construct runtime that you have the correct ordering.
Right.
Yeah. So onInitialize, so this is the magic where, at the beginning of a block, onInitialize happens. Register extra weight unchecked. I actually don't know what this does. But it seems to weigh. Oh, maybe this is, okay, this is actually new code, relatively speaking, that I've seen. But it seems to me, from what I'm reading here, that it may be telling us the weight of the onInitialize function. So here, whenever we do a transaction, we want to make sure that the right fees are being paid and also that our block can handle all of the weight of the different transactions.
Yeah, so this is like it's weighing all the onInitialize, and then you can see right after it's weighing all the onFinalize so that it knows how many more functions it can put into this block.
Exactly. So this is actually relatively new code to me, but this makes a lot of sense, right? Basically, we want to make sure that whatever palettes we're including that for that block that it can handle all the onInitialize and all finds, all the automatic logic before we actually start doing transaction stuff.
Yeah, sure.
So this is perfect. It makes sense and to have it here. Okay, so then we can have some initial checks. Initial checks are checking things like the extrinsic root. So like, is the block where the parent block match the extrinsic root that we have in our system, right? We're checking these things are equal. The tree must be valid. That all makes sense, right? Basic consensus things. And then we actually go and execute the block. Okay, so when we execute the block, of course we do the initialize block. That's what we kind of showed up here with this this code. Then we also do any initial checks. I think initial checks should be...
I think we already passed it.
Oh, yeah. Okay, so this is the initial checks here. Exactly. And then finally, we actually execute the extrinsics with bookkeeping. So here we're actually going through the individual extrinsics, this vector, and we're actually going to execute each one of them.
Yeah, and you can see like the line just before that, this block.deconstruct function, you have, just like we said before, you have a header and then extrinsics. And this extrinsics, it's just a vector. So you have a vec and then a bunch of extrinsics in it, and it's just going to go through and execute these one by one.
Exactly. And so, yeah, so we iterate through them. For each of them, we apply the extrinsic with no note. Yeah, and you can see here, I'm just going to jump down to apply extrinsic. And you can see here that it basically, in the short terms, it actually runs the extrinsic and will return to us whether or not it returned okay or it had an error. And then, of course, let's see what we got here. We do any final checks. And so final checks is kind of where we expect to see our final thing. I think this execute extrinsic actually should be touching this finalized block logic. So let me actually walk through it. Where is this finalized block happening? Give me 1 second.
It might be called outside of this.
Oh, yeah, it might be called outside of this. That's interesting. Okay. This might have changed a little bit since I last seen it, but I guess I would assume that after the execute extrinsics with bookkeeping, this is where the on finalized logic will actually run after this.
So this is just like on initialized, except kind of the other end. It's at the end of the block.
And you can see here, it's just exactly that thing. So one thing to take note of here is that we have this all modules tuple, which is calling the on finalize. And we even had that up here with the on initialize, right? But you can see here the system module actually has custom code written into it, right? So like here, we have some custom code we expect from the system module, like the note finished extrinsics, which is being called directly in the system module. So it's not part of this normal like queue like all the other palettes. And so this is kind of why system is different than the other palettes. It's a frame. It's a part of the framework, and it's assumed in our executive that our system is implemented in a certain way, versus all the other palettes kind of have this more generic API, which can kind of get pulled into this hook.
Right.
That makes sense. Yeah. Yeah. And so after we do the on finalize stuff, we do any final checks. I think the final checks are basically making sure, like, okay, does the final out the state of our blockchain after executing on extrinsic match, all the things that we would expect? Would it come to consensus if we were to share this thing around? And yeah, it's really not that complicated overall. Like, I think you'd have to jump around a little bit in this code, but if you walk that path, we're really just initializing the block, executing the block, finalizing the block.
Yeah, and one thing like to be careful with here is this this naming finalized. We don't mean consensus finalized, like it's in the final chain. In this context, on finalized, this just means at the end of the block.
Yeah, exactly.
Like, this is finalizing the block construction, but not actually finality in the sense of like it's in the canonical chain.
Yeah. That's all right. Maybe we can think of a better name. So I think another thing to note here is, let's say that you wanted to go really deep into Substrate. So, of course, we make Frame the easiest platform to build new runtimes with, in these different palettes. But, it is possible to go and touch and modify this level of code if you wanted to kind of diverge from our framework. And I think you could see here how powerful or how easy it would be to add additional logic or code to the block construction process. So I'll tell you, for a while, we actually didn't have on initialize or on finalize as part of Frame. And it's kind of through our own necessity we added these things in. But you can see it's very simple to add it in if you break down the block structure process to something simple like this, something that has very clear steps. So it's possible that, if you think of a good scenario, maybe you want to make a PR to Substrate and introduce other pieces of logic throughout the different block construction processes.
Yeah, and like one example that's not in the executive module, but we have off-chain workers, right? And so like this is another thing that just gets called at the end of a block.
Yeah, so maybe we can find that here, off-chain worker. Yep, so here's a off-chain worker thing. So this was something that was, again, uses the same kind of pattern. There's all modules. We can assume that all of them could have an off-chain workers logic, and we just run it, right? And then if we actually go take a look at maybe where this is actually run, I guess it's also run in a different file here.
I think it's run at the run at the beginning of a block because it gets called into this.
Yeah, but it's not in this in this file. Either way, yeah. I guess the main point is that introducing something like this was something that happened very recently. And it's something that was possible, again, because we have this really clear and modular platform for basically just like breaking down all the steps of the blockchain. And these are the kinds of benefits you get when instead of building one specific implementation of a blockchain, you kind of say, okay, with Substrate, we're trying to build a generic framework for building blockchains, right? And we look at every layer and we try to keep it as generic and as modular and extensible as possible. And these are the kind of benefits you get when you do that. So all of the crazy engineering in Substrate really comes down to making it simple and easy to extend and modify the framework.
Yeah. So to wrap up, what would you say are like the key points for a runtime engineer here?
Yeah. So one, you really ideally shouldn't be needing to touch executive. You should understand how it works. You should know that when you write different palettes, that what you write in there hooks into executive, whether it's on initialize, on finalize, or even the ordering of the palettes in your construct runtime. And basically, yeah, I mean, just take advantage of the fact that we kind of do a bunch of automatic stuff, the queuing stuff for you, and use that to basically make whatever logic is right for you in your different palettes.
Great. Thanks, Shawn.
Yeah, thanks.